Ladies and gentlemen, welcome to another edition of Intellectual Adda on Creativity Café. I'm Dr. Moin, reader in storytelling and brand communications at Queen Mary University of London, and your host for today's Intellectual Adda. Today we explore a deep question: how emerging science is reshaping technology, society, and the art of leadership. In our previous conversation, we traveled from Einstein to Michio Kaku, exploring how humanity's search to understand the universe can inspire better leadership, wiser thinking, and a deeper appreciation of our place in the cosmos. However, today we take the next step. Modern physics is no longer confined to laboratories or astronomy. It is quietly transforming technologies that will shape our economies, our security, our education, our healthcare, and even the way we solve humanity's greatest challenges. Artificial intelligence is advancing rapidly. Quantum computing promises computational capabilities far beyond today's supercomputers. Quantum communication may redefine cybersecurity. Quantum sensing could revolutionize medicine, navigation, and environmental monitoring. Many scientists now describe this period as the beginning of second quantum revolution. But every technological revolution raises important questions. How should society prepare? How should universities educate future generations? And what kind of leaders will be needed in an age where science advances faster than institutions? Well, to explore these fascinating questions, I'm delighted to welcome back Rear Admiral Dr. Khandakar Akhter Hossain, Vice Chancellor of Bangladesh Maritime University, former Assistant Chief of Naval Staff Material of Bangladesh Navy, naval architect, engineer, researcher, author of over 250 journal articles and 40 books available on Amazon, particularly in the areas of physics, quantum mechanics, cosmology, artificial intelligence, innovation, and the future of civilization. But perhaps what makes him truly unique is that while many engineers study machines and many admirals command ships, he spends his evening reading Albert Einstein, Richard Feynman, Stephen Hawking, and Michio Kaku, asking questions that lie far beyond engineering, shipbuilding, maritime operations, and naval warfare. Admiral and Vice Chancellor, welcome once again to Creativity Café.
Thank you, Dr. Moin. I really enjoy your creative and thought-provoking Adda.
Fantastic, Admiral. It's really fascinating to get you in this Intellectual Adda. I have designed our today's Adda following a story arc. So let's start with Act 1. And the Act 1 is the quantum revelation. Vice Chancellor, people often hear that we are entering a second quantum revelation. What exactly does that mean? And why do many scientists believe it could be as significant as industrial revolution or the digital revolution?
Wonderful way of thinking. The first quantum revolution was a 20th century movement that transformed our understanding of physics, like matter and energy, by introducing the transistor, the atomic clock, the laser, the transistor, and the modern computers. And ultimately, the technologies that underpin today's digital world. The second quantum revolution is totally different. It is a major technological shift focused on controlling individual quantum system using core principles like superpositions and entanglements, rather than simply understanding quantum phenomena, we are beginning to engineer and control them. This opens possibilities for quantum computing, quantum communication, quantum sensing, each capable of solving problems that are currently beyond conventional technologies. Although many of those developments remain at an early stage, their long-term implications are profound. Like previous technological revolutions, the greatest impact may not come from individual inventions, but more the entirely new industries, professions, and way of living they create. History teaches us that societies which prepare early are often the ones that benefit most from technological transformations. Quantum science, therefore, represent not only a scientific frontier, but also a strategic opportunity for nations, institutions, as well as organizations. Dr. Moin.
Thank you very much, Vice Chancellor. That was a phenomenal. I could see that not only have you just explained the second quantum revelation so artistically, but also you have given a message for the leaders and policymakers, particularly those who are preparing to use this revelation for the benefit of the civilization. I particularly like when you said that societies which prepare early often the ones that benefit most from the transformation. So that's a profound message for people who are leading the society. I also like to iterate for my audience that you said one of the things to finish with, that this does not just represent scientific frontier, but also a strategic opportunity for nations and institutions. So I could see that how you are merging science and strategy to prepare the leaders and the organization to grab the opportunities. That's a phenomenal story, Admiral. So let me get into my next questions about comprehending quantum computing, because you laid the foundation, or you laid the background very well for addressing this question now. Many people find quantum computing difficult to understand. How is it fundamentally different from the computers and artificial intelligence system we use today?
Very interesting query, Professor. Classical computers process informations using bits that exist in either 0 or 1. Quantum computers use quantum bits or qubits, unlike normal bits that are only 0 or 1, which can exist in combination of state through principles such as superposition and entanglement, where superposition tests many answers all at once to solve hard math problems very fast, and entanglement, like qubits, together so the state of one instantly changes the state of another. Eventually, this allows certain classes or problems to be explored in fundamentally different way. It is important, however, not to think of quantum computers as replacement for today's computers. They are specialized tools designed and specialized challenges like complex optimizations, molecular simulations, and cryptography. Artificial intelligence and quantum computing should also be seen as complementary rather than competing technologies. AI excels as learning from large data sets, while quantum computing may eventually accelerate computations that are currently impractical. Together, they have the potential to transform scientific discovery, engineering, and decision making. Understanding both technologies will therefore become increasingly important for future leaders, educators, relevant stakeholders, even policymakers. Dr. Moin.
Thank you very much, Admiral. That was a really, really profound answer. I particularly like the thing that you said, that together they have the potential to transform scientific discovery, engineering, and decision making. That's really powerful. While you were talking about technology, but you are also talking about management decision making. And this is very important that both managers, leaders, and the scientists, they should work together to create a future that we could not even imagine. And that's the power of storytelling as well. So that nicely brings us to the next act, Act Two, which is from scientific discovery to societal transformation. And I'm going to ask you a question, Admiral, about quantum technologies and the future of everyday life. So, Vice Chancellor, every major scientific revelation has eventually transformed society, as we all know. How do you think quantum technologies will change everyday life over the next 20 to 30 years?
Well, Dr. Moin, history shows that we often underestimate the long-term impact of scientific discoveries. Few people in the 1940s could have imagined that quantum physics would eventually lead to smartphone, GPS, the internet, modern medical imaging, healthcare, transportations, even agriculture, and many more. Today's quantum technologies may have a similarity transformative effect. Quantum computers could accelerate drug discovery by simulating complex molecules with unprecedented precisions. Quantum sensor may enable earlier diagnostic of diseases, more accurate environmental monitoring, and safer navigation system. Quantum communications promises fundamentally new approaches to cybersecurity through secure information exchange, providing unbreakable or unbreakable codes to protect bank data and private masses with quantum keys, and stop hackers from stealing secret government or personal files. Although those technologies are still developing, they have the potential to reshape healthcare, finance, logistics, defense, education, social welfare, and scientific research. Their greatest impact may not simply be faster computations, but the creation of entirely new industries and solutions to problems that are currently beyond our technological reach. As with previous revolutions, the societies that invest early in research, education, development, and innovations are likely to gain the greatest long-term advantages. Dr. Moin.
Thank you, Vice Chancellor. That was really profound. And the way you actually showed us the story of hope, I would like to say that that is really encouraging for the leaders who are preparing the next generation of society. So my next question to you is about AI and quantum technologies, trying to understand the momentum it can create. So artificial intelligence is advancing at an extraordinary pace, as we know. Do you see AI and quantum technologies as competing revolutions, or will they reinforce one another, and how?
Great questions. Artificial intelligence and quantum technologies are not competing revolutions. Rather, they will strongly reinforce one another. I believe they will become powerful partners in near future. Artificial intelligence depends upon enormous computational capacity and vast quantities of data, while quantum computing offered the possibility of solving certain highly complex computational problems far more efficiently than classical systems. Although practical quantum AI remains an engineering field, the combinations could significantly accelerate scientific discovery, material engineering, climate modeling, and optimization across many sectors. However, technology alone does not guarantee progress. Every advance brings ethical responsibility concerning privacy, security, fairness, and human oversight. The challenges before us is therefore not simple to build more intellectual or intelligent machines, but to ensure they are developed and governed responsibility. University, institutions, governments, and industry must work together to create frameworks that encourage innovations while protecting the values that underpin an open, inclusive, and trustworthy society. Our goal should be to ensure that technological progress strengthens humanity rather than outpaces our collective wisdom. What do you think, Dr. Moin?
That's really phenomenal, Admiral. The message that you have brought is very, very important. As I was listening to you, it becomes clear that the real challenge is no longer whether these technologies will emerge. They already are. The more important question is whether our institutions, our education system, and our leaders are preparing quickly enough. And your message is very, very clear. You said very clearly that our goal should be to ensure that technological progress strengthen humanity rather than outspaces our collective wisdom. So that's really powerful. So let's bring our audience, Admiral, into the realm of Act 3. And the Act 3 is about leadership in the quantum age. So my question to you is about preparing for the quantum age. So throughout history, technological revolutions have often advanced faster than governments, universities, and organizations. How should our institutions prepare for the quantum age?
Brilliant observation. As we see, technological revolution often move faster than society because new tools grow exponentially, while institutions change slowly and laws take time to pass. For example, private companies push a new product fast to make a profit, whereas governments must debate, write, and pass laws to keep people safe. And organizational leaders need times to see if a new tools or technology is safe before they use it. So it is always challenging. As a result, preparing for the quantum age requires much more than investing in new technologies. It requires investing in peoples. History reminds us that technological revolutions succeed when institution, education, policy, organization, and even industry evolve alongside scientific discovery. Universities and institutions must move beyond traditional disciplinary boundaries and encourage its students to integrate science, engineering, computing, ethics, and leaderships. Again, governments should support long-term research where or while developing strategies that strengthen national uh, capability and international collaborations. Industry also has an important role in translating research into practical innovation. Most importantly, institution must become a learning organization and agile enough to adapt as knowledge evolves. Quantum technologies will continue to develop over decades, and no single institution can address every challenges alone. The future belongs to societies that combine scientific excellence with responsible governance, interdisciplinary collaborations, and a commitment to uh, continuous learning. Ultimately, preparing for the quantum age is not only a technological challenge, but also an educational and leadership challenge. Hi, Doctor. What do you think?
That's a very powerful message by Chancellor, because you just categorized it so well. You said that it's not just technological challenge. Obviously, it's technological challenge is there, but it is also educational and leadership challenge. So how we educate our leaders, or how we educate the next generation of societies, that's very important. And you also given some solution, actually, not just left the audience with a statement. You said that it is a need for the organizations or institutions to become learning institutions or learning organizations. They got to be agile to adapt as the knowledge or the technology evolves. That's really powerful. You also acknowledge that no single institution can address every challenges alone. That is again powerful. So that means we need to work together. So your invitation is very clear. You said that the future belongs to societies that can combine scientific excellence with responsible governance. And you stressed on the need of interdisciplinary collaboration and the commitment to responsible and continuous learning and responsible leadership. So that's really powerful. I can see that this small answer that you have given, it has got gems of wisdom for not just one or two stakeholders, for many stakeholders. And I think our audience, those who are really taking our intellectual adda seriously, will be immensely benefited today. Let me take you to the next question, which is about preparing in the new scientific revelations. As you have said the context very well, so let's look towards the future. Many developing countries worry about falling behind in emerging technologies. And it will not be justified, actually, or we will not be able to create an inclusive world if we are not taking all the countries together. What advice would you give to countries that want to participate in this new scientific revolution?
Brilliant question. Okay, let's think like that way. Every technological revolution creates opportunities for those willing to prepare. Developing countries should not measure success by trying to replace everything that larger economics are doing. Instead, they should identify strategic areas where they can build expertise, develop talents, and contribute meaningfully to the global innovation ecosystem. Developing countries can succeed in emerging technologies by focusing on fundamental or foundational education, bringing open innovation hubs, and forming targeted global partnerships. So, investment is quality education, or in the quality education or scientific research and digital infrastructure is fundamental. But equally important is nursing curiosity, creativity, and critical thinking from an early age. International collaborations between universities, institutions, governments, and industry can accelerate knowledge transfer and capacity building. Scientific progress has always been a global endeavor, and the quantum age will be no exception. Nations that cultivate human capital, encourage innovations, and remain open to collaboration will be well positioned to contribute to future uh, discoveries. Sustainable development in the 21st century will depend not only on access to technology, but also on the ability to develop, govern, and apply it responsibility or responsibly for the benefit of society.
Wow,
Yes,
wow,
Doctor.
wow, wow. You have just brought so many contemporary issues and also at the same time showing the solutions. First of all, you said nurturing curiosity, creativity, and critical thinking from an early age. This is really, really powerful thing. I mean, I also, in my class, I teach creativity. I was in my previous university, I had a module for the master level student on creativity itself. So I can see that this is really powerful. You talked about, say, cultivating human capital, encouraging innovation, and remaining open to collaboration. That is really powerful. But what is very, very important is that we were always talking about, or possibly the mainstream debate was about access to the technology. But you said that, yes, access to technology is important, but that may not be the kind of the only solution. We need to also ensure that it's not just access, but also empowering them. So creating the ability to develop, govern, and apply these technologies in a responsible way to benefit the society. So I really see that this intellectual adda is going to a different realm, and I'm really grateful for that and for your contribution. I have got my last question, so we are bringing this intellectual adda towards the end, and this is possibly my most favorite question, and I call it the message to dreamers. Message to dreamers, because many people, those who are watching us, many of them are the dreamers. So, Admiral, if a young student watching today dreams of becoming a scientist, engineer, or leader, what message would you leave with them?
Good. From my childhood, I remember my childhood. I have always been curious about how things work. I always love to asking questions and discovering the answers. This helps us to understand the world, and we can discover new things and solve problems. I would encourage young students never to lose their curiosity. Every scientific breakthrough begins with the questions that someone was courageous enough to ask. Technology will continue to evolve, professions will change, and new challenges will emerge. But the qualities that sustain meaningful leadership remain constant. Continue learning, think critically, work collaboratively, and act with integrity. That is important. Don't be afraid to or difficult problems, because history shows that today's impossibilities often become tomorrow's realities. At the same time, remember that knowledge carries responsibility. Science should improve our lives and strengthen peace and expand opportunities for humanity. Whether you become a researcher, an engineer, an entrepreneur, or a public servant, strive not simply to build better technologies, but to build a better society. For a young dreamer who want to change the world, please always stay curious, keep asking big questions, never be afraid to fail and love others. Remember, 4 key rules for success. Ask why, build things, have passions, and help others. The future will belong to those who combine technical excellence with ethical judgment, intellectual humility, and genuine commitment to serving others. That is the enduring purpose of both science and leaderships. Thank you, Dr. Moin, to ask a nice questions.
That's very powerful. I think I would prefer to become that curious boy, getting this advice and preparing myself. I mean, you said so many things. I mean, what should I'd reiterate? Maybe the last sentence that you said, that is about combining technological excellence with ethical judgment, with intellectual humility, and a genuine commitment to serving others. You also said that don't be afraid to love others. That's really, really powerful. And you sort of smashed it with a statement that that is the enduring purpose of both science and leadership. It's a very bold statement, but this is a very correct statement, an inspiring statement, Admiral. So, Vice Chancellor, thank you once again for an enlightening and thought-provoking conversation.
Thank you. Thank you, Dr. Moin, and your learned audience. I really enjoyed this Adda.
Fantastic, fantastic. So I think I don't have anything to sort of summarize today because you have said so well. Instead, I will just try to do something else. I would finish this intellectual Adda with a quote from Richard Branson. And the reason is that when you were talking about yourself, that you were a child, and I could see that there is a resonance between your way of feeling and Richard Branson. So Richard Branson, when he was in the space, on his spacecraft, surrounded by his team of curious and passionate people, he gave a message to the next generation of dreamers. And he said that when he was a child, he was looking up to the beautiful moon and thinking, wow, what a wonder, what a beautiful moon. But when he was 71 years old, adult, he was in space and he was now looking down to the beautiful art. And then he called the next generation of dreamers and said that, just imagine if we can do this, imagine what you can do. So that's our story of hope today. Ladies and gentlemen, thank you very, very much for staying with us today. And I look forward to seeing you for another Intellectual Adda. Until next time, take care and stay curious. Goodbye.